Good day, viewers, and good day, students. You're welcome to Mr. Oshuko INC. Please, our topic today, you can see this mathematics. Our topic today is laws of indices. This is actually ss1 topic, ss1 first term topic. This is what you see, ss1 first term topic, which is also grade 7. I'm sorry to say grade 10. That's the first term topic. So let's look at indices, laws of indices. Before we talk about the laws of indices, let's define indices. Let's define indices. Now, indices shows the number of time a particular number multiplies itself. The number of time, indices shows the number of time a particular number multiplies itself. Are you seeing that now? So let's just look at this simple example. Now, let's look at this. 2 times 2 times 2. It means 2 raised to power 3. You understand that? Now, this theory tells us that 2 multiplies itself 3 times. Let's look at other number. Let's say 5 times 5 times 5 times 5. This is 5 raised to power 4. Now, it means 5 multiplies itself 4 times. Now, this 4 and this 3 is the indices. You can see 3 is the indices. 4 is also the what? The indices. Because why are they indices? They shows us the number of time this number 2 multiplies itself and this number 5 multiplies itself. But there's something we should understand about this. Let's see when we say 2 raised to power 3. When we have 2 raised to power 3, we have what they call the base number. This is the base. The base is 2. Then the index number is 3, which is the indices, which is also the power. Is 3. Obviously, so another word for indices is also power. So the base is 2. The indices there is what? 3. Please take note of that. Okay. Now let's look at the laws of indices. Let's look at the laws of indices. One of the first law of indices is this. Please let's assume this is m raised to power a. M is the base, a is the what? Index number. So if I have m raised to power a, this is the multiplication law, m raised to power b, it will give me m raised to power a plus b. Where m is the base, a is the index, m base and then index. So you have m raised to power a plus b. How does it happen? Let us see an example how we have something like that. I want to show you why this is the law. This is m. So assume we have 2 raised to power 3, 2 raised to power 3 times 2 raised to power 2. By expansion that we did in our lower classes, 2 raised to power 3 times 2 raised to power 2 means 2 raised to power 3, which is 2 times 2 times 2. If I have to expand this, 2 raised to power 3, then times 2 times 2, that is 2 raised to power 2. Let's multiply it and see what the answer is. I'm going to have 2 times 2 times 2, 8, which is something like 8 times 2 times 2, 4. And 8 times 4 is 32. You see that now? By expansion. But let me try to apply indices, because indices make the work easy for us. Now, if I want to apply indices, I will just say 2 raised to power 3 times 2 raised to power 2. It becomes 2 raised to power 3 plus 2 by the law of indices. So, which gives us 2 raised to power 5. You can see that this 2 raised to power 5 is just the same thing like we have here, 2 raised to power 5. So, whatever answer I have here will still be the same answer here. You can see the indices make the work easy for us. Another law of indices is this is division. M raised to power a divided by m raised to power b. It becomes m raised to power a minus b. Hope you are seeing that. M raised to power what? A minus b. So now let's see how we can have this. M raised to power a minus b. Let's say if I have something like 2 raised to power 5, let's say 2 raised to power 5 divided by 2 raised to power 2. By expansion, I know this is 2 raised to power 5 divided by 2 raised to power 2. So which gives us 2 times 2 times 2 times 2 all over 2 times 2. So we have to cancel. Then what do we have there? 2 divided 2, 1, 1, 2 divided 2, 1, 1. Then we have 2 times 2, which is 4. So let me now use the normal law, the law of indices to solve it. 2 raised to the power 5 divided by 2 raised to the power 2. By the law of indices becomes 2 raised to the power 5 minus 2. And that gives us 2 raised to the power 3. Hope you have seen that. That gives us what? Okay, 2 raised to the power 5. Please, let's check this question very well. We didn't expand it completely. Okay, I think we have to have under 2 here. So we have 2 raised to the power 3. And that gives us 8. So this, we still have 2 raised to the power 3. And that will give you 8. You see, it becomes smaller, easy for us to solve when we are using the laws of indices than the expansion method. Go further. Now let's look at these other laws. Let's say number 3. Any number raised to the power of 0 is 1. How do we have something like this? This any number raised to the power of 0 is 1. Then this another law. Any number raised to the power of 1 is that same number. I can use let's say we have 2 raised to the power, this I'm going to use the division law to do this. 2 raised to the power 3, let's say 2 raised to the power 3 divided by 2 raised to the power 3. 2 raised to the power 3 divided by 3 by 3. By expansion, although we already know, let's just use the law of indices. By the law of indices, 2 raised to the power 3 divided by 3 means 2 raised to the power 3 minus 3. And that is 2 raised to the power what? 0. Then, how do we know that this value is 1? That is 2 raised to the power 0. How do we know this value is 1? Let's go to the expansion. Now, by expansion, 2 raised to the power 3 divided by 2 raised to the power 3 means 2 raised to the power 3 all over 2 raised to the power 3. That is 2 times 2 times 2 all over 2 times 2 times 2. And that will give you 2 divided 2, 1, 1, 2 divided 2, 1, 1, 2 divided 2, 1, 1, which is 1 over 1, which is 1. So you cannot see, this confirms this law, which says anything raised to the power 0. Okay, I can use m, since I'll be using m, I can say, okay, m raised to the power 0 is 1. 3 raised to the power 0 is 1. Any number raised to the power 0 is 1. Then let's look at this one there. Let's look at this. Then we have number 4, when I said x raised to the power, let me use m, because we'll be used to m. M raised to the power 1 is m. How do we have it? Let me use numbers. If I have 2 raised to the power 4 divided by 2 raised to the power 3, I will have, normally, from the law of indices, it becomes 2 raised to the power 4 minus 3. And that gives us 2 raised to the power what? 2 raised to the power 1. Now, how do I know that it is true? Let's use the expansion law. 2 raised to the power 4 divided by 2 raised to the power 3 means 2 raised to the power 4 over 2 raised to the power 3, which is 2 times 2 times 2 times 2 over 2 times 2 times 2. You can see that if I cancel, divide them, this divide this. Inverse law. Inverse law. We actually have 2 of it. Let's use this. Let's say if we have m raised to the power minus a, then let's look at this other one. M over n raised to the power minus a. With this inverse law, what we have is actually 1 over ma. I'm going to tell you why. Then this we have to invert it. It becomes n over m raised to the power minus a. So what happened here? Let's use a simple example and tell you how we got something like this. If I have 2 raised to the power 3 minus divided by 2, right from this same division law, that second law there, 2 raised to the power 4, I'm going to have, by expansion, I have 2 raised to the power 3 all over 2 raised to the power 4. And that gives us 2 times 2 times 2 all over 2 times 2 times 2 times 2. So 2 divided 2, 2 divided 2, 2 divided 2. You can see that I have 1 over 2. Let's leave it that way. Now, let's now apply the normal law of indices. 2 raised to the power 3 divided by 2 raised to the power 4. The normal law of indices becomes 2 raised to the power 3 minus 4. You know, when we are dividing, we have to subtract the powers. So that gives us 2 raised to the power 3 minus, what's 3 minus 4? Minus 1. You can see that it's the same values. This is the same value that gave us 1 over 2, and this same value is giving us less. So which means the end result with this will be what? 1 over 2. So which means 1 over 2 is same thing as 2 raised to the power minus 1, which confirms this law. Hope you have seen that. So any number, I can say If I say x raised to power minus a is in as 1 over xa. 3 raised to power minus a, these are the examples. Let's say 3 raised to power minus 2 is 1 over 3 raised to power 2. These are some few examples. Then likewise this. But let me give some examples on this. In case of this, let's say if I have something like 3 over 2 raised to power minus 2, it becomes 2 over 3 raised to power 2. No more negative value because it's inverted. So there I'm going to have 2 raised to power 2 all over 3 raised to power 2. Hope you are seeing that. But there's one law I want us to look at. When you raise the power to meet another power, raising a power to meet a power. You should understand that. Raising a power to meet a power. If I have something like this, maybe I have m raised to power a, b. I'm going to multiply the powers. ma times b. Take note of that. Example, if I have something like this, maybe I have 4 raised to power 2. 4 raised to power 2 is saying 2 raised to power 2 bracket 2. And that will give us 2 raised to power 2 times 2, which is 2 raised to power 4. So you can see 4 raised to power 2, 4 raised to power 2 will give us 16. 2 raised to power 4 will also give us 16. Thank you very much.